Okay. At the top, they gave you the parent function for sine and the parent function for cosine, and they marked some critical points. So we are going to transform these, and we will use what they give you, 1, 2, 3, 4, 5 critical points each. We'll use the 5 critical points in order to help us sketch the correct transformed graph. So, if I look at my first one, they've got a vertical stretch of 2 on both sine and cosine. So we are going to transform both sine and cosine with a vertical stretch. So it's a vertical change only. So if you look, first we'll fill in as A, B, and C. That's your A value. There's no B value listed, but B is always right in front of X, so it's 1. It can't be 0 or there would be no X there. Does that make sense? Because 0 times X would make it 0. There's no C value. And there's no D value. Okay, so I have a vertical change only. So if I look at my 5 critical points, the only thing that's going to change in my 5 critical points is the Y value, because this is just a vertical stretch. And a vertical stretch is multiplying by your Y value. So that's all I'm going to do. So my X values are going to stay the same. So this first point on sine is still going to be 0, 0, because the X value doesn't change. And if I multiply the Y value by 2, 0 times 2 is still 0. So my first point is still 0, 0. It's right there. So far, everybody okay? Mm-hmm. Okay, so my second point, pi over 2, 1. The pi over 2 doesn't change, because this is not a horizontal change. But the 1 becomes 2, because I multiply my Y value by 2. So it's pi over 2, 2. My next critical point, the X value doesn't change, because this is just a vertical change. I multiply my Y value by 2. 0 times 2 is still 0. My next point is 3 pi over 2, negative 1. So the 3 pi over 2 part doesn't change, but the negative 1 becomes negative 2. And then 2 pi is 0 is still 2 pi 0. It doesn't really look any different, and the reason why is because they scaled it differently. I wish they hadn't, but they did. So we're going to do, is everybody good? Mm-hmm. So we're going to do the same thing for cosine. It's still just a vertical change. So it's only affecting the Y values. So I multiply my first Y value by 2. My second Y value by 2. Everybody all right? It's not too bad, right? Okay, so the next one, I still have a vertical change. This time it's a half, so it's a vertical compression. You're still just multiplying your Y values by whatever the vertical change is. So this is a half. So my X values aren't going to change. Let's see, 1 half, 1, 0, and 0 are my A, B, C, and D. Just real quick, does everybody know where I'm getting these? I'm using this, and your A is in front. Your B would be right in front of X, and I don't have anything, but it has to be 1, or there wouldn't be an X there. There's nothing with C, and there's nothing with D. Okay, so my first value, which is 0, 0, is still going to be 0, 0. Now this one's going to be pi over 2, and I multiply my 1 by half. So this is going to be pi over 2 and a half. So it's going to be right here. So this one is going to look different. So it looks like that. Because this one has been vertically compressed. Everybody all right? Easy, right? Okay. So same thing with cosine. Okay, so that's how does the A value affect the critical points of the overall graph? It is a stretch or compression. Vertical stretch or compression. Okay, now we're going to change our D value. Now if you remember yesterday when we took our notes on the D value, remember we said if you know D, it is the central axis. It is the midline of the graph. So one of the things that I think makes it easier to do the graph is if you know your D value, if there is one, go ahead and do like a little dotted horizontal line there, because that's where your axis is going to be, which means your amplitude is going to be above and below that. So I think it makes it a little easier. So in this case I have sine plus 1, so has your A value changed on this one? No, your A, and so your A value is 1. It has to be, because if you had a 0 here in front, that would get rid of the word sine. So it has to be 1. That's your amplitude. And the amplitude of the original sine and cosine wave is 1. So it goes up 1, down 1. Hadn't changed at all. My B value is still 1 because I still have an X. My C value is 0 because there's no horizontal or phase shift here. And my D value is plus 1. Which means I have a central axis at 1 on both of these graphs. Now, if you're using your critical points to graph, it is a vertical change only. So again, your horizontal values or your X values on your 5 critical points aren't going to change. Your Y values, you're adding 1. So my first point, instead of being 0, 0, is now going to be 0, 1. My second point, the pi over 2 doesn't change, but the Y value, I add 1. So instead of being 1, it's now 2. Pi 0 becomes pi 1. And 3 pi over 2, it was negative 1. Well, when you add 1 to that, it becomes 3 pi over 2, 0. And then 2 pi 1. So it looks like that. And we'll do the same thing for cosine. It's a vertical change only. Your X values aren't going to change. Your Y values, you're adding 1. Okay, so you go ahead and do number 4, and I'll put them up more of them. better. My sine wave is pretty good, my cosine wave is terrible. It's not very wavy, but looks like that D is a vertical shift, just moves the whole thing up and down. My amplitude didn't change. So above the midline and below the midline is just 1. Y'all good? Okay, so on number 5, we now have 2 transformations to the same graph. And in this case, they both happen to be vertical translations. I have a vertical stretch by 2 and a vertical shift by 1. So my A value is 2. My B value is 1 because there's still an X there. My C value is 0 because there's no horizontal shift, but my D value is 1. Alright, so I've got 2 vertical changes. The stretch happens before the shift. So now you can go ahead and draw your midline, because if you have a plus something or a minus something at the end, it is the new central axis. So I can go ahead and put that in. And so I know, because sine always starts on the central axis, that that's where my first point's going to be.
So you're just really,
Okay, so now my y values are going to change, but my x values again are not, because neither of these transformations are horizontal transformations. So pi over 2, if you want to go back and look at it, it's pi over 2, 1. So now I have to multiply 1 by 2 and then add 1. So it should now be pi over 2, 3. Now if you think about it, this makes sense. Once I found, and just so you guys know, it's whatever is easiest for you. If you want to find critical points and graph all the critical points, then great. Usually what I do is find the central axis and figure out my amplitude. If I can do that, I don't need to do all my critical points. My amplitude is 2, which means it goes 2 up from the central axis and 2 down from the central axis. So here's my central axis, I have to go up 2. I have to come back to the central axis, and then at my next point I have to go down 2 from it. So that's how I usually graph them. But whatever's easiest for you. Wait a second. And then on my cosine wave, cosine doesn't start on the central axis, it starts an amplitude above the central axis. So I identified my central axis as being 1, and then I know my amplitude is 2. So my cosine wave has to start 2 above that. It doesn't start at 2, it starts 2 above the central axis. Or if you want to do it by critical point, your critical point for cosine is 0, 1. I have to multiply that 1 by 2 and then add 1, which means I should be starting at 3. Everybody good? Okay, so now we have some horizontal transformations. Take a second, fill in your A, B, C, D. Okay, so now what we have is a horizontal transformation only. It's not a vertical transformation. My A value is 1, my B value is 2, there's no C and no D. Okay, now here's where you have to be just a little bit careful. Remember, what is with X, what is grouped with X, which this is, grouped with X, is backwards. So it looks like multiply by 2. but you actually divide by 2. Okay, so my first critical point for sine is 0, 0, so it doesn't matter what you do, it's still going to be 0, 0. But the next critical point was half pi 1. Now I'm going to take half pi and divide it by 2. Dividing by 2 is the same thing as multiplying by a half. So if I would have half pi divided by 2, that's the same thing as half pi times 1/2, which makes this pi over 4. So your new x value is pi over 4, 1. So it's going to be right there. Then my next x value was pi, or my next ordered pair was pi 0. But because that horizontal change, I have to divide by 2. So instead of pi, it's now half pi. And then you can probably see the pattern after that. Now that's one completed cycle, but now that you have the pattern, you can complete the curve if you wanted to. You can just keep going. But one cycle's enough. If you get one cycle, you're good. Okay, so same thing for cosine. Now your original point on cosine is the point 0, 1. This is just an x change, so the first one's not going to change at all. Because if I divide 0 by 2, it's still 0. So I still have it right here. The next point was pi over 2, 0. So it's now going to be pi over 4. So it looks like that. Y'all okay? Next. A value is 1, my B value is 4, no C, no D. Alright, this is a horizontal change only. It's backwards of what you think, so even though it looks like multiply by 4, it's not multiply by 4, it's divide by 4. You're dividing all your x values by 4, so 0, 0 will still be 0, 0. Okay, so my first x value besides 0, 0 on my critical points over here was pi over 2. So I have to divide that by 4, which is the same thing as multiplying by a fourth. So it's going to be pi over 8. So, where is pi over 8 on this graph?
Between 0 and
Exactly, between 0 and the first line, right? Because the first line is pi over 4, right? So it's going to be right here. I did a couple of cycles because it's so small, so. And same thing on this next one. The first point doesn't change because it's at 0. Okay? Okay, so now A value this time is 1, B value is a half, no C, no D. Okay, so a half looks like divide by 2. But instead of dividing by 2, this time we're going to multiply by 2. So if my first critical point, well 0, 0 is not going to change. But if my next critical point was pi over 2, instead of dividing by 2, I'm going to multiply by 2. So if I have pi over 2 times 2, what happens? It's just pi, because those 2's are gonna cancel. So my 0, 0 stays the same, and my next point is gonna be pi
1.
1.
1731.
So now, what I would probably do to graph is now that I see what that means for me graphically, that's 1, 2, 3, 4 spaces away. That means my next point has to be 4 spaces away, and where is it gonna be?
On the axis.
On the axis. So I can just count 4 spaces and put a dot. 2, 4. And then 1, 2, 3, 4, and that one's gonna be below. That's the great thing about these things being, they have periodic, is they have patterns. And if you can figure out the pattern, you don't have to do each individual point. Similarly, on this one, I had my first point at 0, 1, that's not going to change. But my next point was at pi over 2, 0. But because of this half, that's the same thing as multiplying by 2, it's now going to be a pi 0. And if you look at it, that makes sense to what we said yesterday. If the b value is less than 1, then it's a stretch. And that's what's happened, is that these curves have been stretched out. So b is a stretch or compression. Horizontal stretch or compression. Alright, a value is 1, b value is 1, c value, negative pi over 4, d value 0. Okay, so it looks like minus pi over 4, but we all know that's really plus pi over 4. Your whole graph, this is a phase shift. Your entire graph is just going to shift to the right pi over 4. So, if you look, your original dot on sine is at 0, 0. We have to shift that now. We're going to shift it right, so it's no longer going to be at 0, 0, but it's going to be at pi over 4, 0. Your next point was at pi over 2. Now it's not going to be a pi over 2 anymore. We're shifting it over a fourth, so it's at 3 pi over 4, which would be right here. So everything just gets shifted over. Same thing for cosine, which normally starts at 0, 1, but now it's going to start at pi over 4, 1. This one's shifting the other way, because the plus pi over 4 is shifting back. So next we have two horizontal shifts happening. So our A value hasn't changed, so it's still 1. Our B value is 2, which looks like multiply, but that means we're actually going to divide. Our C value is minus pi over 4. Okay, so normally our sine wave would start at 0, 0. We have to multiply and shift. Everything happens backwards with x. So even though there's parentheses, that looks like you, because of the way this is written, it looks like you should do this first, the shift, and then the multiply. But because everything's backwards with x, we do the multiply, which is actually division, and then the shift. So 0, 0, you first multiply by a half, divide by 2, because that looks like multiply by 2. That's still going to be 0. And then we shift it right pi over 4. So your first point would be right here. Okay, and then your second point, which was pi over 2, your second critical point was just pi over 2. You first divide by 2, which is the same as multiply by half, which gives you pi over 4. And then you add a fourth to that. So you're now at half pi. Quarter and another quarter gives you a half. So your next point would be right here. So we'll just for the sake of making sure we understand what we're doing, remember we've got a horizontal compression 2, which means you're actually dividing by 2, and then a shift. So my next critical point would be pi. I divide that by 2 and get half pi, and then I add a quarter to that. So 50 cents plus another quarter, that's 3/4. So you get 3/4 pi 0, which is right here. And now you can probably see the pattern, so you don't need to do it anymore. Is everybody okay? Does that make sense? For cosine, your first critical point is 1, 0. I like it, 0, 1. So the first thing you do is multiply by a half. That doesn't change anything about the 0. Then you add a fourth. So instead of being at 0, 1, you're going to be at pi over 4, 1. Your next critical point was pi over 2, 0. So you multiply by a half. That would put you at pi over 4. But then you have to shift by a fourth. So you'd be at half pi. And your next critical point would be pi. Multiply that by a half. So it'd be pi over 2. Add a half. That'd be 3/4 pi. Once you have the pattern established, you can just go. Everybody all right? It can get a little confusing sometimes, but. All right, so now we got one that's got every kind of change. It's got both a vertical and a horizontal stretch/compression. It's got a vertical translation and a horizontal translation. So your A value, remember that's your amplitude. Your A value is 2. Your B value is 2. Your C value is minus pi over 4. And your D value is minus 1. Once I know my D value, I can put my central axis. That might help me with my graphing. This is also, this pi over 4, that's your phase shift. When we took our notes just a minute ago, that is the beginning. That's where the period begins. Remember, for sine, that's on the midline. So I know that it used to be at 0, 0. Now it's going to be shifted over. So I could put my first dot. I know it's going to be at pi over 4 because that's my phase shift. So it would be right here. And then I know I'm going to go up from there. I also know I'm going to go up how many? Because what's my amplitude? 2. I know that from there I am going to go up 2. Only thing I have to figure out is what about my horizontal compression? Before I go up, how far over am I going? So I can go back and look at my second critical point for sine, which was pi over 2. I have that 2, my b value of 2, which means I have to divide by 2 or multiply by a half, which puts me at pi over 4. And then I know that I have that shift by another fourth, so I should be at half pi. So when I go up 2 for my line, I'm going to be at half pi, so that would put me right here. So now that I know what my compression has done, every critical point is a fourth apart, one line apart. So I know where my next one's going to go. It's going to go from here back to here, and then down, from the central line down 2. Everybody okay? Make sense? We can do the same thing for cosine. I drew in my central axis, and I know that cosine always starts one amplitude above the central axis. That's the bell. We'll do that on tomorrow, and then I'll give you the